Hi, my name's Jez and welcome to this introductory video on searching and sorting algorithms. So without further ado, let's make a start. I'd like to begin with looking at the topic of searching algorithms, methods that you're required to learn if you're studying for GCSE especially, different methods that computers use in order to search through a list of values or letters or words or whatever. In these examples, we're going to be using numbers, list of numbers, finding a particular number in a whole series. Okay, so let me just share my screen ever so quickly. There we go. Okay, so if we have our list that we want to search for, maybe we've got a 7, 21, 52, 59, 68, 92, 94, 99, 113. Okay, I'm just going to copy that so I don't have to type those out again. There we go. So we have our list of numbers, and let's assume we want to find 99. So 99 is the number we are looking for. So I'm just going to pop 99 up there. Now there are two methods, two common methods we can adopt in this case. The first is what we call a binary search. Now, a binary search is an interesting method. Basically, the first thing it does, it goes for the middle of the list. So the first thing it does is head for the middle. In this case, we have a middle value of 68. Now, because the list is in order, we are able to say whether the number we're looking for, in this case 99, is 99 higher or lower than that middle value of 68? Well, it's higher, isn't it? 99 is greater than 68. So with that in mind, we can remove half that list already. Okay, so we've only got 9 values in our list, but imagine if it was 9,000, a list of 9,000 items. We could get rid of half that list in one simple step. And then it's just a case of repeating the process, always going for that middle value. Okay, in this case, there isn't an exact value bang in the middle, but we could go either side and just repeat the process. Is the number we're looking for higher or lower than that middle value? And again, 99 is higher, so we can again remove the half that we don't want, and we're gradually narrowing down that list until we're able to land on our number that we're looking for. So that's a binary search. Now, with computer science, there are always advantages and disadvantages with anything. And it's the same with these methods, these algorithms. The advantage we have with a binary search is that it's quick. It's quick. And we know it's quick because of the example we've just gone through. We can get rid of half the list at a time. So we can remove large quantities of numbers. The disadvantage is, as you can probably see, the list has to be in order. A binary search will not work if your list is not in order. So it's like an extra step that you need to put in place to ensure that your list is in order. Now, the second search method we need to learn about is linear search. A linear search. Now, a linear search does exactly what it says on the tin. It searches in a line. And what I mean by that is it basically takes our list of numbers and starts at the beginning. the first step of a linear search, it goes to the beginning, picks the first value out. Is that what we're looking for? No, it's not. So now it moves on to the second one. Is that the value we're looking for in this case? No, it's not, because we're looking for 99, don't forget. And it will keep repeating that process over and over again until it finds the number we're looking for, in this case, 99. Advantages and disadvantages again. Advantages of this method is that it's quick and easy to implement. So it's a really simple search method. If you are having to code, even pseudocode or Python or any other language, if you have to code a linear search algorithm, it's quite easy to do. And as you can probably guess, the list doesn't have to be in order for it to work. Okay, our list of numbers are in order in this case, but we could have a random set of numbers that are out of sequence, and a linear search would still work. The main disadvantage of a linear search is that it takes a long time. It takes a long time to find our number. So if we have our list of 9,000 numbers and our number we're looking for is right at the end, it's going to take a long time to work its way through every number till it gets to the one we're looking for. So again, highlighting the fact that there are pros and cons with anything to do with programming. So these are the two main search algorithms that we need to learn about. Now, let's move on to sorting algorithms. So sorting algorithms are slightly different. And again, there are two main methods of sorting. So what I'm going to do in this case, I'm just going to put in another sequence of numbers. So let's go with 66, 21, 38, 15, 89, and 49. Okay. One main method that we need to learn about is called a bubble sort. A bubble sort. And this is quite a common sorting method, a bubble sort. And what a bubble sort does is it has our sequence of jumbled up numbers. Its aim is to put them in order, don't forget. And it does that by first selecting the first pair of numbers, 66 and 21 in this case. It then compares the two, and if necessary, it'll change the order around. So those two numbers in that pair are in numerical order. So in this case, I'm going to freehand draw the numbers. So 21 and 66. So we've swapped those around because 66 is greater than 21. Okay, we can then, let me just fill in the rest, 15, 89, and 49. There we go. Okay, so we just swap the two pairs around. We then move on to the next pair, in this case, 66 and 38. And again, we need to swap those two around because 66 is greater than 38. So that leaves our sequence currently looking like this: 38, 66, 15, 89, and 49. Okay. And then we repeat the process again, moving on to the next pair and seeing whether they need to be swapped around. And once all the pairs have been checked, that's our first run. We then need to repeat that run again, taking a pair at a time, making sure that those pairs are in the correct sequential order, and eventually our whole list will get ordered. Now, it's called a bubble sort The way I remember a bubble sort is that the high numbers sort of bubble their way to one end of the list eventually, and the low numbers sort of bubble their way to the other end. It's just the way I remember it. And just like with search algorithms, sort algorithms have pros and cons as well. So the advantage of a bubble sort is that it is able to check quite quickly if a list is already in order. Okay, and this point will become more apparent and more important when we look at the next method of sorting. But in this case, a good advantage of a bubble sort is that it can quickly check whether a list is already in order. And you'd have to agree it's quite a simple process, isn't it? It's quite a simple process to adopt, just taking pairs and just comparing those two numbers and swapping them around. So if you have to write a bubble sort algorithm in pseudocode or Python or another language, it's quite easy to do so compared with other methods. A con or a disadvantage is it's not very efficient. It could take a lot of runs in order to get a finished ordered list. So generally speaking, it's not as efficient as other methods. So that's a bubble sort. Now, the last one I want to cover is to do with sorting again. Okay, and this time I'd like to use letters in this case. Okay, we've used numbers before, but I want to demonstrate that these search and sorting algorithms also work with numbers, but also words and letters. So let's put together, let's see what we've got. So F, P, A, L, T, D, K, H. So that's our list of letters that we need to sort and put them in alphabetical order. Okay. And the way we're going to use, the method we're going to use in this case is called a merge sort. A merge sort. Now, what a merge sort does, it splits that list in half. Okay, and it sends half this way and it sends half that way. So we have, excuse my handwriting, F, P, A, L on this side, and we have T, D, K, H on that side. Okay, we then repeat the process of splitting them in half until we're left with pairs. So in this case, we have our F, P, oh, excuse me, it's not very neat, I do apologize. We've got the A and the L, we've got the T and the D, and we've got the K and the H. Okay, so now we're left with these pairs. Okay, so we need to get to this point where we have those pairs of values, and then it's just a case of merging them back together, but in a more ordered fashion. So what we'll do, we will look at these pairs first, and what we do, we put these in alphabetical order. So FP are in alphabetical order already, AL, TD isn't, so we have an FP already in order, but we need to carry it down when we're demonstrating or writing out our result. But FP, and we also have AL in order, but TD isn't. So we're going to swap those around to be D, T, because D comes before T, and we have K and H. So we need to swap those around as well. So H, K as well. And then it's just a case of reversing the process. So we merge two pairs together and stick them in alphabetical order. So these two will come together and these two will come together. Okay. And we have these four values now, D, H, K, and T. So these groupings, at every grouping stage, we put them in alphabetical order, and then we just bring the remaining groups together to, I'm going to type now this time, okay, to form an ordered list. So we have A, D, F, H, K, L, P, and a T. Okay, so that's a merge sort. You know what I'm going to say next: advantages and disadvantages. Can you think of any advantages that a merge sort has over, say, a bubble sort? Any ideas? Well, it's to do with efficiency. Okay, a merge sort is far more efficient than a bubble sort. Okay, because it has structured stages, we are able to sort of more or less accurately predict how long a typical merge sort will take, how many steps or how many stages it requires. But yeah, generally efficiency is the main key with a merge sort. The disadvantages is that it has no way of determining whether a list is in order already. So even if your starting values are already in order, it will still go through all these stages and finish with the same result as what it started. Okay, so if you remember, the bubble sort can determine straight away, it'll just do one pass, bang, that's it, it knows it's in order. With a merge sort, unfortunately, it still has to go through all these stages before it, it determines whether it's in order or not. So yeah, that's a massive disadvantage. And yeah, and because of that, it apparently it can use a lot more memory when it's processing these lists. So there are bubble sorts and merge sorts. So this is a very brief introduction in searching and sorting algorithms, and this is where I wanted to finish today. So always remember, whether you're trying to implement a search or a sort, or you're asked questions about such methods, always consider the pros and cons, because nothing's perfect in computer science, nothing ever is, but it's always worth remembering what advantages they bring to the table, but also the disadvantages. And we'll leave it there. Thank you very much.